Now that I've shown you how to make it, I want to talk a little bit about why to make it, tell you a little bit about my personal story, because that's most of what I've got to share. I'm just a farmer who decided to focus on biochar because I saw the opportunity and I wanted to share it with other people. So on my little farm up in Massachusetts, I started clearing land, and I quit my job and said I'm going to grow stuff instead because I hated my 9-to-5. And I quickly found that I was sitting on a big sandbar, which is what Cape Cod is where I live. It's sand and rocks and sand and pebbles left behind by the sheets of ice that came down in the last ice age. So I quickly started trying to figure out how to turn that sand into usable soil and stumbled across biochar in a book called 1491, which is a story of the history of North and South America before the Europeans got here and started messing with it. And in a little section in the back of that book, it talked about these Native Americans that lived along the Amazon that made this incredibly fertile soil to the point where the scientists were going to study it because they couldn't figure out how they did it. And I've actually traveled down there and seen it. It's called terra preta, which means black soil or dark soil. And they also have terra mulata, which is sort of outside of the terra preta, which is a dark soil that was also created for growing things, and very, very obviously created on purpose by people. So you go and you stand in this field in the Amazon basin, which I always pictured the rainforest as being like the most fertile place in the world. And it's actually the opposite. It's forest because there's lots of water and lots of sun, but it's not fertile. It is solid clay. To get to the sites that we went to, you had to climb 30 feet of slippery, solid clay. They had to put stairs and steps and boards across it just to walk across it. Solid, thick clay. So this is what the people were living on there and trying to grow things in. And it must have taken them generations and generations to figure it out. But somehow they figured out that if you put charcoal and other waste products and compost and so forth in the soil, you're going to get much better growth out of your crops. And they did it to the point where they spent thousands of years and generations, and now it's piled up and still there. Some of it thousands of years old, has not washed away like all the other nutrients in the jungle. When you get this clay base and you get all that rain in the rainforest, it just washes all the nutrients away. We actually got a chance to walk back into the rainforest, and they showed us you'd go in and you'd take the leaves that pile up away, and you see the roots of the trees are growing up out of the ground because they're competing for whatever nutrients are falling out of the forest. They're not growing down into it. It was really bizarre to see, but there's all these roots coming up toward you if you sweep away the leaves and so forth. So they're going after that stuff as it's decaying faster than it can even become soil. But in the spots where they found the terra preta, that they now understand is an old place where there was a city of people living. Literally walking through this farmer's field, you reach down and grab a fistful of the soil, and it's black and rich and smells like the most wonderful soil you've ever seen. And there's big chunks of pottery in it, everywhere. So it's really obviously anthropogenic soil. At one point I said to the farmer, I said, wow, that's a beautiful orange tree you've got there. I mean, this orange tree was very large, and the branches were so overloaded with fruit that they were touching the ground. They couldn't hold all the fruit, and the fruit were huge. I thought they were grapefruit at first. And he said, no, that's an orange tree, and they were all dark green. They weren't even ripe yet. And I said, how long has that tree been there? Oh, that's only 2 years old. 2 years old. That's how good this soil is. So now they compete for that soil in Brazil and other South American places. They actually mine it for potting soil and sell it in the cities. They talk about it growing back, that you can actually take a layer of it off. And I believe what's happening there is that it is so rich, and the stuff does grow on it so much, and it brings in so much biology, and that is all decaying into it, that it actually promotes the building of the soil that you want. Even though you've already taken some off of it, it does keep growing stuff so fast that then decays that it does come back to some degree. It's obviously not coming back as terra preta because nobody's adding more burnt carbon into it, but it is promoting the buildup of the soil, even though most of it's gone, what's underneath. So I think that's where that legend is coming from, because it has actually been documented by scientists down there that it is building the soil even after they've harvested most of it. So I found out about that. I started making it in little cans on fires in my own yard. As I was clearing my land, I'd make char, and I grow these turnips that are ridiculous, that have been grown in Eastham, Massachusetts for the last 150 years, and nobody really knows where they came from. I mean, talk about legends. There's all sorts of ideas on who started these things. But they're big turnips to begin with. And they're worth a lot of money to me because it's a niche crop that people go crazy for them. No problem, I can sell every giant turnip I can grow, no matter how big it is. So when I tried the first time, after reading this book, making a little charcoal and putting it in a row with my turnips, the turnips doubled in size compared to the rows where I hadn't done it. And I thought, whoa, this is too good to be true. And I tried it on everything I could find. And it helped pretty much everything on my farm. Not everything. There were cases where I did some damage, and we'll talk about that too. Maybe John can talk about that more, on things not to do with biochar that can cause problems, especially in the short term. But by putting a strip into the turnips, you could see from hundreds of yards away the difference in those plants. It looked like a different species of plant. And it literally, the ones that I put it on were twice as big as the ones that I hadn't put it on. But I've grown them 28 pounds one year, 32 pounds one year. I mean, the thing was the size of a basketball. And you look at it, this big ugly root, and people think, oh, that's probably all pithy and no good to eat. I cut that thing up. I made over $100 on one turnip.
What variety?
It's an Eastham turnip. I brought one with me.
I hope you did.
Now that turnip just sat in the back of my truck and rode here 1,000 miles at a 60-mile-per-hour wind. And that's a baby. That's not a full grown. It'll be 2 or 3 times that big by the time I harvest them. And the leaves are very good to eat too, even when they're that big. The bigger they are, the sweeter they are.
Is this one just your traveling turnip, or do you put a lot of them in buckets?
No, I went out in the yard before I went out in the field and just grabbed one and stuck it in a bucket to take to the symposium. So that spent a week at the symposium. Under the fluorescent lights, I thought it was dead. And then Pat stuck it in the greenhouse, and now it's, but it's an amazing plant. It'll grow after it's been buried in the snow will melt off and they go back to growing. And that'll turn into a 7-foot cedar in the spring, all covered with beautiful yellow flowers, all of which are also edible, that I found out from one of my chef friends.
How long will it take for that one to harvest, to be harvested?
Well, that's the same as most of the ones in my fields up north, they're probably growing faster up there because they like the cold weather than it would down here, but
After the frost?
as soon as we get a frost, we'll start harvesting now. Yeah, but you can't harvest until you get a frost because it really changes the flavor. So that's how I got into biochar. Once I realized what it was doing for my soil, I then went online and thought, I wonder if anybody else is doing this. And of course, there's a whole international community of people doing this through the IBI, which is the organization that did those posters out there, is the big one that I recommend if you want to learn more.
So my name is John Nilsson, and I am with Char-Gro. Char-Gro is a newly formed LLC here in Mills River, based out of stuff me and Bob were already doing. I put this up here earlier because if you haven't seen this video, it's pretty neat. It's a BBC video. It's a little dramatic, you know. It starts out dun 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 dun. You know, you get into it. But in the search for El Dorado, they do talk about selling the soil. They do talk about how they didn't do slash and burn in those days. They did slash and char. They were smarter than us. And Thomas Mann totally, through the work in his book 1491, through the work of archaeologists, you can see that he's basically totally rewriting U.S. history, because it's the history of the U.S. prior to Columbus. And it's really good because they were managing land on a very large scale here. So the whole thing that we've been taught when I was a kid anyway, oh, there's just a few native tribes and they were just over on the outskirts here. And no, there were really high populations of people managing really big acres of land. So even the whole conservation ethic to get it back to this special place, this Eden, the Eden that the first white folks got to was being managed, you know. So it's pretty interesting stuff, and I have another piece about that. But I first want to get everybody on the same page with the search for El Dorado, Terra Preta. That's showing you what native people were doing in both North and South America prior to colonization. And what was interesting about those folks, they were feeding a huge amount of people. The first Spaniards that came up the Amazon said the agriculture was on par with anything they'd seen in Europe. And the buildings touched each other for 14 miles on both sides of the river. And as far as they could see in were settlements. So it was a very, very high population. And they had to grow a lot of food. And they did not have steel. And they did not have domesticated animals. So you can imagine how tough their agriculture was. It was all by hand, and the only edge they had was superior soil fertility methods. And that's how I first got into it. Pat's probably not around yet, but Pat was one of the first person that said, hey, they do this thing, you know, and putting charcoal in the soil. And the first thing I said was, yeah, that's going to fly. How could you afford to make the charcoal? That's just, skip it. And then another guy mentioned it, and I don't know who told me next, but they said, hey, there's this guy at the University of Georgia, and he's making power while he's making the char. And that's when I went, okay, I'm in. You know, so I went down there and learned from him what they were doing. That was a company called Aprita. I don't know where they are these days. They've kind of imploded. But they were getting to this thing. Well, wait a second. If we can make some profit at this thing and use the energy, now I might be able to go back and go, hey, maybe this is good for agriculture. Concurrently at the time, I come from the compost industry, and I'm a consultant in that. And what I was working on is how do you get the biology into the growing medium most efficiently as possible. So there I was making potting soil with compost, where the potting soil contained about 40% by volume compost. And I could even make it so it could suppress damping off, which is a common Rhizoctonia disease in greenhouses. And I was like, wow, this is going to be great, you know, because I can do this. But we were selling our potting soil in little bags to White Flower Farms in Connecticut, and they were using it for growing all these bulbs, and everybody loved it. The project lasted 1 year, and then they canceled everything. And we're like, I thought you liked this stuff. Yeah, we did like it. Well, what was the problem? They didn't keep track of it's a mail order business, and they didn't keep track of their postage till the end of the season. And our product weighed 2 to 3 times more. So the cost of shipping, they had the same price on the shipping, totally killed the project. Somebody probably got fired. And so I realized, well, wow, I can't deliver this biology very far. Maybe 50 miles in a tractor trailer. In potting soil, it weighs too much to go into conventional markets. Great idea, it's not going to fly. So, and that potting soil still does sell, and a lot of organic growers will put up with a heavier weight potting soil, but a conventional grower won't. He's got machinery and he's got flats that are all designed to very light mixes. So how do you deliver the biology lighter? And I played around with calcined clay and expanded shales, and then I had this one consulting job with these guys, and they had played around with some carbon, and I was like, whoa, this stuff's off the charts. So from there, I started helping develop. The original Char Grow is a concentrate that is based on biochar, carbon. So it's basically carbons, microbes, substrates, and foods. And with one of the people that I was consulting for, me and him went on to create a trade secret formula. And we get, when you put it in about 3% by volume of a potting soil, we get a 51% increase in tomato yield at first pick. So that was concurrently going on while I was hearing about Aprita, and I quickly thought, wow, we've got to figure out how to make our own char, or else it's still going to be really expensive. And so that's what got me into biochar, and then all the applications like Bob, I quickly was like, wow, this works. Where do you get the thing that makes it? And what scale, and can it go into agriculture, and around and around and around on that. And that's what led me to where I am here today. No soil becomes Terra Preta just because you added char. Okay, so when we were at the growers school this past spring, one of the guys who presented got really into the char, and he said, oh man, I put it in my soil, and that was my worst year ever. And the reason why is char by itself is that charcoal filter. It sucks up stuff, sucks up water, nutrients, organisms. So if you don't have a lot of stuff going on already in the soil, it can tie up stuff, reduce yield the first year. So it's like that charcoal filter, right? In your water filter, maybe you have a Brita filter or something like that, and it's got all the char balls in there, and the water's coming through and it's filtering, and after about a year they say, throw out the filter. That's because the filter's now loaded. Well, in the field, the little chunks of char are like the filter, and they're going to suck up stuff. So if you want to stack the cards in your favor, you want to load the filter. You're going to load the char. So now it holds the biology you want. So that's why blending with compost and things like that can get this so that it'll be releasing. And the other thing that's going on in that you can think of the char as this. I always start with a golf ball. A golf ball has these little dips in it, and if the char is made well, then those little dips are cleaned out, and now you got internal pore structure, so that up to you can have a gram of char have the surface area of 2 tennis courts, and that seems hard to believe, but it's all that internal pore structure. Now, what that does for the soil is, it holds a little nutrient, but not as important as it's holding the organisms that do the nutrient cycling process. So when a plant's growing and there's sunlight, photosynthate is made through photosynthesis, and carbohydrates and sugars go into the leaves and into the roots, and the plant puts it out of the roots. So the plant's putting out simple sugars and carbohydrates out of its roots continuously. It's doing that to feed the organisms, to get them on their infection sites, because the organisms, through their hyphae and their enzymes, can get nutrients that are out in the soil that the plant can't get by itself. So that's what's going on. And what char does is it's a safe harbor for those organisms. It's the super concentrate they can hatch out, even if things got bad out here, like what could get bad? High salt fertilizers kill the process. So this bioinoculant that I've made called Char Grow Concentrate, it works, but you can kill it. And so it's a great biological tool. We have chemical, physical, And now we have biological tools that we can use, and the char is key to that. So the char by itself doesn't do the trick. It's when it interacts with organisms. And so the extra part of the Terra Preta, what happened was, now you go to the next paragraph, example of Terra Preta cultures. What they found was the natives had these large areas where they were adding the char to their feces. Basically, they had a waste management problem too with a lot of people in high concentrations. So you'd have your manure piles, human manure, and you could put the char over the top, and that would help to sterilize things and get it to break down. And so now there's more people who have looked at that. And so by doing that method, it led to the char being loaded with the nutrients, which is what we're doing in the soil amendments we're going to make here. And the surface of the char is oxidized, and so you're changing the surface chemistry, and it can hold more. And those two things together is what gets you the Terra Preta. So the Terra Preta didn't happen overnight. It was loaded with manure, and they now think it took up to centuries to get its full fertility. But the thing is, it doesn't stop. It just keeps building. And so some of the scientists out there are going, oh, wow, you know, it's crazy. You can't add 100 tons per hectare. Well, no, you wouldn't want to. You wouldn't be profitable anymore, right? So, but you can add a little bit at a time, continually building your soil over time, and that's really how you get to this big benefit in fertility. So I wanted to bring that up. This is this group here. I try to remember how he said. Ithaca is what he said. Hans Peter Schmidt. He was at the biochar conference that just happened up in Massachusetts. He Skyped it in. He couldn't phone it in, so he Skyped in his presentation. He did his Skype presentation, and he showed all the applications. And I think one of the most interesting things here on the second page, the cascaded use. So he's like an agricultural R&D firm, nonprofit, figuring stuff out. I believe he said he was on something like 40 farms with this and repeating and repeating what he was doing. So he could put it in the silage. And then the silage is fed to the cow, but he could also put it in the feed. So it goes into the feed additive supplement. Then it's on the floor where the cows are walking around as a litter additive. Then it can be, after the manure comes out in a slurry, throw a little more in there. So all the things he's doing are taking it through the food system, through the cow even. It's sucking up nutrients. It's changing that surface chemistry, making it more and more loaded. And then even water treatment in fish farming. So I wanted to put this out there, and this is on the Living Web Farms website, but I wanted to put this out there because you can start to see that there's so many applications. And in bioremediation, char is going to actually disrupt the market in that traditionally they've used either compost, and it breaks down too easy, or they've used activated carbon, which is really expensive. And now we have a cheaper form. So like in remediation, one of the things, there'll be a new road, or there'll be a runoff problem, and they'll do this thing. This is side view, and that thing is just a tube with some material that's filled with char and a little bit of compost. So the water runs off, hits that, and it's constantly being filtered, cleaned as it goes. And then this has a little bit of compost in it, so pretty soon it's the berm, and you got a continuous living water filter. So to me, that fits into the proper use of biochar. In other words, added to the soil, permanent sequestration of the carbon that's there, doing a function, an ecological function. Here it's filtering water. Out in the field, it can grow crops more effectively, and I even think cheaper. And that's one of the things I hope to do more of as I go down the road. So we've heard of, hopefully everybody's heard about the Terra Preta South America. There's an American version also. So I talked about Thomas Mann rewriting American history. So this was something I wrote up for some of my friends around Thanksgiving. And the first page, it talks about cation exchange capacity, and I'll explain some of that. But then the second page is a letter I was sending around. So The first Europeans to come to the U.S. were amazed by these new wild lands and the type of soil in the grasslands in the middle of the U.S. There's a picture in there. All this brown area are these grassland soils. Well, what they found these grassland soils had in common was that they're very fertile. And so that some of the same folks that did some of the testing on the Terra Preta decided, hey, let's look at these soils in the U.S., and they're called mollisol. That's just the soil scientist's name for it. So what they've learned about these mollisoils is that pre-settlement fires, so prior to colonization, they know that pre-settlement fires produce charcoal, okay? And that charcoal is much more abundant in these soils than they previously thought. Fires were a common practice that Native Americans used to maintain grasslands. If you have a grassland, you're going to have more things that eat grass out there, buffalo, elk, that kind of thing. So they were doing that to maintain grasslands. Okay? When I worked in Kansas for Kansas Crop Improvement Association, which is a group of seed producers, I'd be driving home at night and I could see on the horizon a line of red. And that was, a whole town was out there burning the prairie. They were still doing it. And the reason why they do that, it maintains the grassland for grazing and it kills the woody species. So the fire goes across the prairie and just burns the tops of the grass. But any shrub that's sitting in there, it burns the wood and it chars down into the ground. And with buffalo and everybody else out there, some of that's getting spread out. So Native Americans were doing this on a big scale. I don't know if you can still do it today, but certainly when I was in Kansas, they were still doing it. And so these scientists came in, they studied. I go, okay, what is this? So the biochar accounted for 40 to 50% of the organic carbon of this mollisol soil, so of the one that's the most common in the grasslands. And then the quote from them that I really like is that essentially the entire contribution of organic matter to the soil's cation exchange capacity could be attributed to the cation exchange capacity of the char. Okay? So what that's saying is pretty much all of the cation exchange capacity of these soils comes from biochar. So now what's cation exchange capacity? It's the ability of the soil to hold positively charged cations, positively charged nutrients. So, you know, soils in the south, you know, a lot of them, cation exchange capacity is 4. The guy that was at the growers school had that really terrible year. The next year, his cation exchange capacity from a small amount of char went to 8. That's really hard to do. It's really hard to get cation exchange capacity to move at all with just compost, yet double, okay? So you can think of it as like a bank vault, right? And it's nutrients sitting in there. Depending on how big it is, you can't stuff any more nutrients in. So you can't hold any more nutrients that would be non-leachable, but still root available. But as the cation exchange capacity gets bigger, the box gets bigger, the vault gets bigger, you can hold more fertility. That's how they did it. That's how they did it in the South American lands. So you're building cation exchange capacity. So what this paper went on to say is basically that pretty much all the fertility of these soils, right? So the first colonists come here and it's this amazing Garden of Eden and the populations of animals are all over the charts. Well, the main predator of the animals is gone. 90% of the population of the U.S. crashed, just like in South America. What happens was the first Spaniards brought the diseases of domesticated animals and other diseases that they had built up resistance to, but the natives did not. They crashed the population. The people who are taking care of the land are gone, and all this fertility is sitting there. And now we have actual proof that the fertility of the, you know, the breadbasket of the U.S., if you picture it in my mind, this is the U.S. The breadbasket of the U.S. comes from this charcoal. So basically the fertility, just like in the Terra Preta, was the biochar added prior to colonization. So that was the real wealth of this country. And the colonists happened to get there, and there weren't many people around anymore. Pretty nice. So the source of that is abundant and stable char residues in soil, implications for soil fertility and carbon sequestration, a bunch of different authors. We'll put this up on the site too, so you have it. It's a pretty technical paper, and I just wanted to extrapolate it down to what I could easily get and use. I'm a soil scientist, but I feel like if I can't do something with it right away, then it's just fun reading on a Sunday morning, you know. So let me take this another step. So cation exchange capacity again. That grower had a 4, and in a year or two, he was up to an 8. He was thrilled. He just couldn't believe it, okay? So sandy soils, light colored sandy soil, which we had a lot of it here, has a cation exchange capacity of 3 to 5, okay? When you start getting up into real good loamy soils, like up in New England and some of the soils deposited from the glaciers that are nice dark soils, you could get up to maybe 10 to 15. You know, they did have some of that in the Midwest, but they really mined it down. A lot of them aren't very good. Even California, you know, the big valley there, a lot of them are much lower than that. But in Amazon soils, they've found soils that were that high. And so that's off the chart. So what this says, and the reason why as a soil scientist I got so into it, is because what this said is we can permanently change soil fertility. The charcoal, they've dated it, the half-life they think is 1,000 years. So even if they're 50% wrong, that's still 1,000 years of fertility we can build. Now, how do we make it as profitable as possible? Because now this rule has to go back into the field. How's that going to go? You still got to make a lot of char. That's part of what we're demonstrating here. You got to make a lot of char, and it's got to work in the field. Well, char grow concentrate works. That you put in a potting soil when you start your plug, and so you put in the potting mix for your transplant. And what you're doing there is, with a little bit of char and a lot of biology packed onto the char, your transplant, there's actually a picture on that poster out there. Your transplant, at the time of transplant, let's say this is a normal one and this is the char one. It might be 25% bigger. Looks a little better. You put that in the field and you can't tell the difference, but then at flowering, it flowers earlier, it yields earlier, and it can yield 51%. That's pretty much where we've gotten to. That was 4 years of replicated trials at Virginia Tech. So you can get there, you can grow a super transplant using chars as part of your biological mix, and you can get a higher yield at first pick, and then with each pick it dwindles down, and you can make your decision when to end your picking due to disease or the market. But so there you can do that, and when we looked at the nutrients, we were doing that compared to conventional agriculture. We were doing that at about 50% less fertilizer required. Now we're talking, now we're getting to something that can make people some money right away. It's not easy though, because you have to change your way of thinking. It's a biological tool. So if you use high salt fertilizers, gone, you kill it, because you're killing the biology. The char will still be there, and the biology maybe hatch out next year, but you've killed your benefit. So you're working with an organic potting soil. You don't want a lot of high salt fertilizers, as little as fertilizer as possibly actual. And you go, you know, say you got a tomato transplant, you're going to go 6 to 8 weeks. At the time of transplant, you want a starter. So instead of using a high salt fertilizer, use a low analysis, something like a fish emulsion could be put in. Okay, now you got them in the ground, and maybe you got fertigation or drip. On the drip, again, low salt fertilizers, low analysis, and you'll be able to carry that plant out. And now we're talking a way that we can make agriculture more profitable with the char. So that's, once I got to that, I was like, okay, now we're rolling, you know. With that amount, that's only in that, I'm running out of page. It's at about 3%. So the inoculant, which contains char is in the potting soil at only 3% by volume. And then that, when used correctly, also at the time of transplant, there's a cover crop being put down. So that's an extra energy boost for the microbes. And with proper practices, you can get to a better yield at less cost. So that's where biochar, the rubber meets the road in terms of what it can do in agriculture. And so that's why this CEC thing is so important. It's just a measure of what the soil can hold. So that got me really going. And then, like I said, like Bob, we were sort of scouring the planet. Where are we going to find a machine that's going to work? I was negotiating with all these companies and trying to get agreements. Somebody's got this, somebody's got that. And it was a lot like my experience in the compost business. You know, you got a lot of people talking about it, a lot of desktop machines, you know, on the page. They looked really good, but very few on the ground. And the further I got, the less I found. And so I looked at that one out of University of Georgia, and I thought that was going to be great. They imploded. A number of companies were doing the cans. Well, that's not good enough. And then my measure of what was good enough is that I had to get to that profitable as possible. In other words, if I can't make char without using the heat, then I might as well buy a char from somebody else. There's plenty of char out there, not always of good quality, but why would I do it? Well, then I met Bob, and I'd heard about him, and he had a little metal box thing, and I was like, you know, it's probably anything happening yet. And then I found out, oh, he is using the heat. So he was taking the heat out of his metal box. Water was being heated. It came under a greenhouse, and he was using it to dry wood. We're in the new version of that. This is a wood kiln. We can heat water and run it to these fan convectors. There's also pipe in the ground. We can heat the floor. We added on a solar application. The back of it is the sun can come into the attic, and when there's enough sun, the fan will come on, it'll start running heat in here. So we're really using the energy well here, and then we can take the energy to the greenhouse too. So now we're multitasking our char. You know, we're getting it to do multiple functions for us. And so that was the other piece I wanted, and that's what we're going to demonstrate here more and more. And the idea is we can take it out to more and more people and show them that this can be done on different scales. We happen to be at this scale. Personally, I thought we were going to be about 1/3 this scale when we started. I was like, little greenhouse, little wood kiln, you know, and then it got bigger. But that to me is the real promise of biochar, that we can do these things and make it profitable and start to you know, retask some of this stuff that people were throwing away. And one of the things I want to make clear is there are a lot of folks that'll say biochar is just going to cause us to cut down more trees or waste crops, you know, like corn to ethanol. It's just going to be corn to biochar. I don't really think so. I think we got a lot of room there before we'll ever get to that. Every storm, there's lots of waste. I know a guy up in Maryland, this guy Pogo. Every time there's a big ice storm in the DC, Baltimore area, it's like $1 million in 7 days. I mean, it's just, there's so much trees coming down, and his job is to cut them, and take them, and put them on his place and chip them up. And so what I believe in is that we don't even need to get into that debate about, oh, we're going to grow trees to chop them down to make char. There's so much waste out there, so much waste. And most landfills, on the side of the landfill was where they've been dumping all the shrubs and trees and brush all those years. So I think we'll be mining landfills.
That was one of the things that they changed on the EPA requirements for the landfills, was there was so much stuff going into them, they made them push the stream aside.
Yep.
Which is the proof of exactly what you're saying.
Yeah, we should be taking that. I remember when I was in New Jersey, the farm that I work with up there, who co-owns the char formulation with me, the char grow concentrate, it was, I think it was Gloucester County. They had like 80,000 yards of chips per year or something. And we were just like, oh my God, it's a gold mine, you know. But there were so many hoops to go through to even talk to those people, and we didn't have a char unit. We were still shopping. And so Bob's char unit became the char unit I could use because it had a lot of good things to it. One is that the shapes and sizes of the material coming in can be pretty big. You don't have to make a certain size material and go through some conveyor to, you know, suddenly you're up to hundreds and hundreds and hundreds of thousands of dollars, you know. Now we got a unit that can work with different materials. We can use the heat. Bob, of course, was very interested in all the energy applications, so I said, okay, let's make that happen here. So that's how we got here. And I wanted you to see this because this is called the cascaded use. So there's different applications. So with this transplant, the amount of char I'll put into the ground is so tiny, it's almost non-existent. But when you're making char, and as we get better at making amendments more profitable, you'll be able to, and we're working with Virginia Tech on this. Let's see. Picture this is your field. You can have raised beds, you know. They're doing permanently raised beds, and you can grow cover crops on them. And he's working on a machine that can basically put the char down right down the row. And that's what you do with this. If you use the char grow concentrate, you only put it right where the plant's going to be. So we're making an amendment now we're calling a char grow source. We'll show you some bags out there. So we can apply it right where the plant's going to be, right down the planting row. He's got a thing where you can open it up, drop the, we're calling it char grow source, which will be a fully loaded char, right down the slot here, and then in that slot you can transplant right behind it. So now you can get up to more mechanized agriculture, and now you're applying quite a bit of char. You're permanently changing the fertility. That'll reduce your energy needs over time, and you can keep going each time. Or in a field situation, again, you go right down the row, you know, maybe a 2-inch wide area, right where the plant's going to be. And now if you're rotating that out, maybe the next time you go this way. And so now you can permanently build your fertility of your soil, but you do it by placing it right where the plant's going to grow, because that's where the money is. You know, that's where you're going to make it happen. So that's why I wanted you to see this. The idea of think of cascading uses. Think of, okay, I use it for the transplant, but then I want to build the soil at the same time, so maybe I put some in the soil. And large-scale agriculture, say this is the field now, out in the Midwest where they laser grade, all the water runs to a point. Well, that's where all their nutrients are running off too. You could have a char box sitting right there collecting the nutrients, put them back up onto the field. The USDA was working on that in 2009. I don't know where it's gotten. But if you think of multiple uses, that's what you're trying to do. You're trying to get synergy. The char by itself doesn't work. It's the char with the biology with the foods with the cover crop. When you multiply all those pieces together, that's how you get to better yield at less cost. So,
John, have they done anything with human urine? Because we need to get it out of the waste stream.
yeah, in Sweden they're doing that on a big scale. The farm in Tennessee does it. There was at the char conference there was a company. Their porta-john was just for urine, and they were taking it and making it into fertilizer. And I said, get that down here. That one should not be there. That should have char in the back. He hasn't made it yet. I'll have to go bug him again. But you could do that.
Can you explain more what you're talking about?
What, more about what I was talking about?
Yeah, urine for fertilizer.
Yeah, so you got this char, and it sits by itself, and it doesn't do much. But you load it. Once it's loaded, it'll do things for you. So human urine comes out sterile. You could put it into the char and make that your amendment. That's basically what we're talking about.
May I augment that just 2 seconds? Most people don't understand that human urine is very high in phosphorus. This is what causes the algal bloom. So when you put it into water and put it in your toilet and it goes into through our sewage system, it goes into the French Broad River because they can't filter out either the nitrogen or the phosphorus. And so if a man pees into a jug, he stops all of that, and he saves the water that was being used to flush it, okay? and he's got this stunning raw material. It's got a little salt issue, but
Yeah.
I've got studies on both brassicas and corn from
Yeah.
as far away as Thailand and
Yeah.
Sweden. It's amazing.
I like this guy.
Yeah. Okay, another question?
Moloscience, is that the name of the?
Oh, the type of soil?
Yeah, what's
Molosol.
the North America Terra Preta?
Well, I don't know if I'd go that far. This is a straight soil science term for the type of soil. If you didn't get to see that,
Well, we saw it.
yeah.
The blog post we did has that all on it.
Okay, yeah, okay, the blog post. The idea at the end there, so the next time we're thinking about biochar, we need to give thanks to the biochar makers that came before us. You know, because,
So I wanted to comment about that.
Yeah.
I'm from Iowa, and I've done lots of things when I used to be a teenager for people that were trying to look at the soil and
Yeah.
how deep the black soil is.
yeah,
It's not a few inches or a few feet. It, in the really good soil.
It's deep.
Is deep.
yeah,
Far, far older than our 15,000 years or 20,000 years.
Right, right,
Think
right.
that there were humans on this part of North America. So certainly lightning and other factors.
oh yeah, yeah, there were other fires.
So we can't attribute it all.
No, not all.
To humans.
Not all. I'm just saying when they did the cation exchange capacity test, that's how they came to that. Yes, so they were naturally fertile too, no doubt. Yeah.
We're coming into the season of Christmas, so there's going to be a lot of Christmas trees that get piled up that are not being used, but also that has a lot of sap in it. Is that still a good source?
Oh, yeah.
All carbon's a good source. Did you bring your char art?
My chart.
Yeah.
Yeah, we've got lots of char art here.
Our logo for our company is the is pine cone. So you could char a Christmas tree, but the drier the tree,
Corn
the
cob.
better.
Doesn't Christmas trees have a lot of pollutants in it though? They make them with huge amounts of, pesticides and herbicides and everything else. Christmas tree farms are notorious for being pretty poisonous.
You know how they get rid of, if they've got barrels of pesticides and herbicides that they need to get rid of? They pyrolyze them, they cook them off or burn them. If you can take those molecules and get them hot enough and combine them with oxygen, you can change them into things that are inert, that are not going to hurt people. And there's actually big companies that go around doing that. They remediate by taking those chemicals and cooking them hot enough and under pressure or whatever it takes. But so in the same processes that we're using in our tin cans out here, you can actually annihilate a lot of those. I'm not going to say all of them by any means, and I'm not a chemist, so I can't do the chemistry behind that. But a lot of them, that is how they get rid of them, is to burn them. So I wouldn't be too concerned with that one on a Christmas tree farm. I mean, you can get into the organic stuff to the nth degree, and sooner or later, it's all around us. And
Well, you don't want to poison your biochar also, you know.
right, which is why we're not going to use things like painted wood or construction waste that has paint in it or galvanized nails. Things like that can be glues. Certain glues could be a contaminant, especially pressure treated. Anything that's green, you don't want to use that because that's got lots of chemicals, mostly arsenic and copper and stuff like that that may not change under those conditions. So it's wise to think about it and look back through. I'm not sure about Christmas trees. I've charred a lot of Christmas trees. They're easy to char, and but that's a really good question.
But the ones that are grown up your way don't get that kind of spray. There's a lot of those that are still raised the old way. The one that you're talking about is what we have up in Southwest Virginia, right?
I think
Yeah,
there's
it's
plenty of
just
non-organic Christmas tree farms around here.
Yeah, no, I'm saying that up where he is, it is not the same thing. I'm wondering about the change in the USDA and the Forest Service in terms of prescribed burnings. My daughter worked in prescribed burns, and it would seem that we've done just about everything wrong in the last 100 years in terms of of keeping the carbon sequestered, because we stopped all the fires in forests. We stopped all the fires in the plains because we put crops on all of it. And so what you're talking about is how do we stay with the current tremendous amount of farming and get that and get the stuff back to those.
Right. It's a good point. There's a lot of situations where we tend to think in terms of we got to get rid of this waste, so we're going to burn it. And we don't think about what we're throwing away in the process. But my company, New England Biochar up north, we've done a number of consulting gigs out west where we will go in and teach the people that are trying to get all that nasty old fuel that's in the forests out of the way so that it's not available for forest fires, but instead of turning it into just a pile of ash, turn it into carbon that's then sequestered in the forest itself. So we can, things that are already going on, we can enhance them to work with the biochar, to work with the carbon cycle. If you want to get farmers to do something, show them the economic benefit of doing it, and they'll figure out how to do it. There's nobody more innovative than farmers and gardeners. So if we can just motivate them that way, show them they're going to grow more plants, grow bigger plants, grow healthier plants, and it's going to cost them less money to do it, and they'll go do it. So in a way, my list is backwards for this audience. I should be starting with number 4. I should be telling you why you're going to make more money if you use biochar. And I believe it's true. You can. You can make more money. You can grow bigger, better, healthier, more drought-resistant plants with more nutrient density in each plant. And there's lots of science behind all of that. I'm not a scientist. So you have the advantage of me not telling you all the tiny details of how that's going to work. I'll try to explain it from my point of view, but it's just my idea of how it works. And how it works is we make this stuff, we put it in the soil, you get it around the roots of the plants, and it's amazing what it does. There's levels of energy in this that we haven't begun to understand, that I know there are people here in this room do understand it intuitively, that there's more going on there than meets the eye, that we can explain even with science. And one of the funny things that I find at all these bigwig symposiums with all the egghead scientists looking at this stuff is that they're always trying to break it down into these, why does it work? Why does it work? And in the process, they're getting it down to the point where, okay, the chemist will come and tell you, well, the chemistry, there's carboxyl groups that are holding this and that, and it's way over my head. And then you get the physicist, and he'll be saying, oh, well, the hydrophobicity of this and that is going on, and that's going to make that work. And then you get the soil scientist who comes up and says, you know, this is going to make your soil more porous, and it's going to do this and that. And all of those things are true and wonderful, and I'm glad and I thank God for all those people who can study that stuff so much more intensely than I can. But what I feel my gift is that I can come and say, you know what? This does a whole bunch of things at once. And it's because it does all of those things that it makes a huge difference. And you can do a lot of scientific experiments getting you down into those little details, and they can't see it. They can't see that it works because it does all of these things at once. Okay, for instance, it holds the biology, but it holds the water. Why does it hold the biology? It holds the biology because it's got the physical structure that the biology loves to move into. There's actually different size holes, if you looked at this under a microscope, that are holding the different size bacteria and fungi, all of which are helping your plants, most of which are helping your plants grow. And at the same time, it's holding on to the nutrients that biology needs to survive and likes to eat. So it's providing housing and food. It's like a welfare system for biology. And it's holding onto the water as well. It's a big deal on Cape Cod with my sandy, sandy soil. After it pours rain, 2 days later, I better be irrigating or my plants are going to dry up and die. So the question is, why does sandy soil dry out so fast? It's just the water's going through it. It doesn't hang on to the water. There's not much organic matter there, which is what's going to hold on to it. And this acts like a sponge, to the point where I did my own experiment, very non-scientific, I guess, but I took a bucket of my soil and I put it in a couple of old plastic sherbet containers that you could see through, and mixed 10% biochar into one of them and left the other one as the control. And then I filled them with water. I punched holes in the bottom, filled them with water, and let them drip till there was no water left in them, and set them on my sun porch to see what would happen. And promptly forgot about them until about 3 weeks later. And I went and looked at them. And of course, the one with the just soil was bone dry. And the one with the biochar in it, you could still see the moisture against the sides of the container. It sounds like snake oil, I swear, when I start going on about how many things you can do with this. It works in the sandy soil because now it becomes that sponge that's hanging on to the water. And it also hangs on to the nutrients the same way. So you have to use less fertilizer every year of whatever kind you're using. Hopefully it's compost and good natural organic fertilizers. But you don't need to use as much because it's not getting washed away. It's being held on to. Now that's a secondary benefit, which doesn't make me any money directly, is that that same phosphorus and nitrogen isn't going to end up in the groundwater, which ends up in the pond downstream from me, which causes the algae bloom and all of that. Okay, so it's filtering it essentially, but it's also hanging on to it. One of my ideas is to build a boat to put in the pond down where it's got the algae bloom, filter the water through a big boat full of biochar, pull the boat out and dump the biochar on my field, because now I've got all the nutrients out of the pond with my filter, and I'm putting them back where I can use them. So it's another whole way of looking at it is we're sorting out the chemicals. We're sorting them out from where they do damage and putting them back where they can help.